Hi guys, today we're going over a review of Precalculus/Algebra 2. The first thing that you need to do here is you need to find the x and the y-intercept, the domain and range, and sketch the graph with no calculator of this beautiful equation. So when you read the equation y equals the square root of 9 minus x squared, the first thing that you need to realize is that this is in the form of a semicircle. And this semicircle is specifically at the top, okay, above the x-axis over here. So if you have that this is x and this is y, obviously, you do know that the radius of this semicircle is going to be 3, okay? So hopefully that you see that it's going to be the square root of 9, which is 3, okay? So after that, I would just go here and, I would draw the 3, maybe here. 1, 2, 3, and then 1, 2, and 3 over here, okay? And then I would do the same here with the same scale. So I would just 1, 2, 3, okay? So with this being said, you know that this is going to be your 3, your positive 3 here, your negative 3 here. So I would just try my best to draw this beautiful circle, okay? So my circle is not very good, but you got the point, okay? So obviously I'm going to be including this part, okay, and this one as well, okay? So that's how your graph looks like. So it's pretty easy to see that the x-intercepts are going to be negative 3, 0, and then it's going to be 3, 0, okay? Now the same way that you can see that the y-intercept in this case, it's going to be the point 0, 3 over here. Okay, so that's your y-intercept. Now remember, the domain is going to be from left to right. So you can see I usually use interval notation. It's going to be from negative 3 to 3, okay? And then similarly, the range, you know that it's going to be from bottom, top. You know that it starts here and it ends here, so clearly you see that with respect to y, this is going to be 0 and this is 3, okay? So you have that it's from 0 to 3 and you are including the 0 and the 3, okay? So it looks like this in interval notation, and that's it for this example. For the second example over here, what you have is again pretty similar. You need to sketch the graph, no calculator. Okay, so here you don't have as much instructions, you only have to graph it. To do a rough sketch, I always look at here in this case, where the piecewise function breaks. In this case, you have that this is a 2-piecewise function, okay? So x squared minus 1, which you know that this has the form of a parabola. And then over here you have 1/3 x minus 2, which obviously it's a linear equation with slope positive. Okay, and this happens when x is greater than 0. This happens when x is less or equal than 0. Okay, so for this one, you can draw, there's several ways of kind of like doing the sketch. What I'm going to do here is I'm just going to do a table, okay, of values, okay. You might tell me, how do I know which values to pick? Well, here's the key. For sure you are going to select the 0, right? So I would do the 0, the 1, 2, and then negative 1 and negative 2, okay? So what are you going to do? The negative 2 is less than 0, so you know that negative 2 squared is 4 minus 1. That's going to be a 3. And then you have negative 1 squared is 1 minus 1. That's going to be 0. And then you know that 0, you plug it here, then it's going to be negative 1. 1 is going to be over here, and that one you know that it's going to be 1/3 minus 2 is going to be negative 5/3, and last but not least, you're going to plug here the 2, so it's 2/3 minus 2, that's going to be negative 4/3. Okay, so here you have your values, and now what are you going to do? Well, you know that this has the form of a parabola. Basically this 3, okay, are going to be part of your parabola, okay? Since I don't have a scale, again, I'm going to do the 1, 2, 3 there to do my rough sketch. So 1, 2, 3, 1, 2, 3, and then you have over here 1, 2, 3, 1, 2, 3. Okay, so you have that it's going to be -2 and it's going to be +3, so it's going to be somewhere here. Okay, and then you have that it's going to be -1 and 0, which is over here, and over here is going to be 0, -1, so 0, -1, you have that it's here. This is including because you have the equal. Okay, so now you can draw here your parabola on this side. Beautiful. And then here you know that this is going to be your linear equation. What I would do here is I would plug the 0 here, so you have that it starts at -2, but that one is going to be an empty circle. Okay, when I plug the 0 here, you know that it's -2. I'm not including it, but that helps me to guide the equation. Okay, so after that, you know that -5/3 is a little bit less, well, more than -2 in this situation. Okay, so somewhere here. Okay, and it doesn't need to be perfect because that's a fraction, and then you have that the -2 is somewhere here. You might do a better scale for yours, but you know that that's going to be a linear equation. Okay, so with slope positive. Okay, so you have that situation, and that's pretty much it for this problem. Okay, for the next one, let's look at the next one. You need to find the asymptotes, the horizontal, vertical, and maybe the slant, the symmetry, intercepts, and sketch your graph with no calculator. Okay, so for this one, it should take you to Algebra 2/Precalc. You need to know that the higher degree exponents for the top and the bottom, they are the same, meaning exponents are the same. So in this situation, you have an horizontal asymptote. The horizontal asymptote that you have is 3 divided by 1, so you do know that it's y equals 3. That's going to be your horizontal asymptote. After that, you can see that the vertical asymptote, you are going to make sure that you can cancel everything here, which you cannot cancel anything. Therefore, I set my denominator equal to 0 and I solve. So what you have here is that your vertical asymptotes are going to be x equals 2 and x equals -2. Okay. If you remember from Algebra 2 and Precalc, you do know that if you have an horizontal asymptote, there's no slant asymptote. Okay, and after that, you know that the x-intercept, we're going to set this equal to 0, and you know that this, when I have this, okay, you know that this happens at 0. Okay, so this is going to be 0, 0. Therefore, you have 0, 0 is also your y-intercept. Okay. So once you see this, you start graphing, and similarly, I don't have the scale, so let me draw my 1, 2, 3, 1, 2, 3, and then 1, 2, 3, 1, 2, 3. Okay, that should be enough. Okay, so I start with my horizontal asymptote. You know that your horizontal asymptote is going to be over here. Okay, so you have this. Now your vertical asymptotes are going to be one over here and the other one over here. Okay, after that, you graph the only point that you have in this situation. Okay, so what are we going to do here? Well, you can recognize that you have an equation here that it's going to point out towards the, you know, the down direction here. So you do know that this part of the equation goes like this. Okay, and if you remember the asymptote here, okay, since you have that this, the multiplicity is 1, it's going to be opposite to this one. Therefore, you know that it goes like this, because this arrow is opposite to this one. Similarly, since the multiplicity of this one is what's that, odd, okay, it's going to be the opposite of this one. So you have this situation over here, and please remember that this is a rough sketch of the graph, so that should be enough. Okay, you can label this to 2, and yeah, this is 3, and that's pretty much what you can do. Okay, so let's look at the next one over here, the last one on this page. we have another rational equation. What you have here is, you might tell me, hey, I can take out the x, but I cannot cancel anything, so I don't have a hole. Okay, so it's clear that you don't have any holes here. So when you have that this, the degree is 2, this one, the degree is 1, so you have that the polynomial at the top, the degree is bigger than the bottom, so you know big on top. Okay, so you know that you don't have an horizontal asymptote. Okay, if you remember button, okay, back in algebra 2, that one tells you that there's no horizontal asymptote, which tells you that there is a slant asymptote. Okay, but first let's do the vertical. The vertical is pretty easy to see since nothing cancels. You know that that's going to be x equals 1, that's going to be your vertical asymptote, and after that let's find the slant asymptote. As you remember, we should do long division. Well, you could do synthetic, but you know that I love long division, so let's do it. Okay, so if you have this, what are you going to do? You need to make this x an x squared. How are we going to do it? With the x here, you multiply x times x. That's going to be x squared, and then you know that this is going to be x squared, and then we're going to have a negative here at the front. So x times -1, that's going to be -1. Okay, so you have the -1 here. Okay, after that you are going to, and that one is x, I forgot the x. Okay, so then you cancel this. Okay, don't forget that this one it's technically positive, so you have a 3x over here. Okay, so after that you are going to take down whatever you have. In this situation is a 0, take it out. Okay, now you compare this 3x with the x. Okay, what are you going to do to make this x a 3x? You know that it's +3. So 3 times x is going to be what? 3x. Remember, we're going to put a parenthesis and the negative in front, and then +3 times -1, that's going to be -3. So you put -3 here. Okay, then you cancel this. Remember, this times this is +3. Okay, and your denominator is +3. And I don't know why I did it, because with this we had enough, but whatever, it's there. So in case that you forgot how to do long division. Okay, so you have y equals x plus 3. That's going to be your slant asymptote, which you can see that it's a linear equation. After that, we're going to do the x-intercept. If you remember, for the x-intercept, I'm going to equalize this to 0, okay, because I can pass basically what you're going to do for the x-intercept, let y be equal to 0. So in this case, you have that that 0 is going to be equal to x times x plus 2, because I factor out the top. So you have that x is going to be equal to 0 and to -2. Okay, so you know that the x-intercepts are -2, 0 and 0, 0. Obviously this is a y-intercept again, so that's pretty cool. Okay, so I have my y-intercept over there. Okay, so now I'm going to graph. Okay, again, I'm going to do here my scale, otherwise it's going to be a mess. 1, 2, 3, 4. 1, 2, 3, 4. And over here, 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3. Okay, so I think with that is enough. Okay, so let's start with the vertical asymptote. The vertical asymptote is x equals 1, so we know that it's going to be over here. The slant asymptote, you know that it's going to be y equals x plus 3. So you know that it has y-intercept at 3, okay? And then you do know that the x-intercept is going to be -3. Okay, so it's going to be here. So with those 2 points, it's more than enough to do my slant asymptote over here. Okay, over there. And I would do it more broken so you can have it clear that it's an asymptote. Okay, after that, you are going to grab your x and y intercepts. Okay, so I start with my x-intercepts. You know that it's going to be -2, 0. And then the beautiful point of 0, 0. After that, you know that this is going to be, in order for this to happen, you have something that looks like this. Remember to keep the shape pretty close to the asymptotes. Actually, this one is pretty bad, so I would do it closer to the asymptote there. Okay, so then where do you have the other piece? It would be over here. Okay, and that would be enough for this one. Obviously, you can put the -2 here, the -3 if you want. That's not required, but in order for that to be a little bit more clear for you. And that's it for this page. Now for these two problems, again, this should take you back to Algebra 2. Okay, so what you're going to do here is, I see that this looks like a cubic equation, therefore I would move the 12 to the other side, having something pretty user-friendly, which is x cubed plus x squared minus 12x less or equal than 0. After that, I could factor this. Okay, so you can clearly see that we can factor it as x times x squared plus x minus 12, it's less or equal than 0. After that, I'm like, hey, I can factor this even more. You're right. So I can factor that as x times x plus 4 times x minus 3, it's less or equal than 0. With this being said, after that, we're going to do a number line on the table. Okay, so what do you have here? Well, my number line, let me draw the number line here. Okay, so what are the numbers that I care in this equation? So you care about the 0, the -4, and the +3. Okay, so let's graph them. Okay, so obviously you have that the -4 is the smallest. After that you have the 0, and after that you have the 3. Okay, so this is your number line. Remember, infinity, negative infinity goes to the left side. Okay, so after that, if you remember from Algebra 2, what we were doing, we were putting all my factors here. Okay, so you have that situation. You are going to plug a number in between negative infinity and -4, not being the -4. Okay, so that one, when you plug a negative here, that's going to be negative. Okay, because negative here, -100 is going to be -100 here. If I plug -100 here, that's going to be negative. -100 here, it's going to be negative. After that, you are going to plug the -4. The -4 here is going to be negative. This one is going to be 0, and this one is going to be negative as well. Okay, after that, you're going to plug a number in between -4 and 0. Okay, obviously I would pick -1. -1 here is going to be negative, over here is going to be positive, and over here is going to be -4. Okay, which is negative. When I plug the 0 here, that's going to be a 0. When I plug the 0 here, that's going to be 4, which is positive, and when you plug the 0 here, it's going to be -3, which is negative. Okay, after that, when I plug a number between 0 and 3, I would pick 1 in this situation. You can pick 2, right? Or a fraction, but that it's in between 0 and 3, but I'm just going to be simple. Okay, so if you plug 1 here, that's 1, which is positive. Over here, that's going to be positive, and over here, that's going to be negative. Okay, after that, you have that 3. If you plug 3 here, that's going to be a positive number. 3 here, it's going to be 7, which is positive. 3 here, it's going to be a 0. After that, last but not least, you are going to plug a number in between 3 and infinity, which I would pick 4, honestly. So you know that 4 here is positive. Over here, it's going to be 8, which is positive, and over here is going to be 1, which is positive. Okay, after that, to refresh your memory from Algebra 2, you do a line, and then you're going to perform the operation that you have here. Okay, this is a multiplication of the 3 things that you have, the 3 factors. Negative times a negative, it's positive, times a negative, that's going to be negative. Then we have over here, whatever times a 0, that's going to be a 0. We see a 0, and I can go ahead and put the 0 here. I know that this is going to be 0, and this is going to be 0. Okay, over here, this is where the things get interesting. Negative times positive, that's negative, times a negative, that's positive. Over here, you know that positive times a positive, it's positive, times a negative, surprise, surprise, negative. Okay, then we have that over here, what's going to be that all positives, you know that this is going to be positive. If you remember from Algebra 2, over here, I was highlighting back in the day. Okay, so what do you have here? I have that I want less or equal, okay, than 0, okay? When that happens, think about that, when this happens at less than, so we want the negatives, okay? And I also want the zeros, okay? Good. So you recognize that the pink ones are the parts that I want. Therefore, in interval notation, what do you have? Thus, the intervals that I want are from -infinity to -4, including the -4, okay? So you have this, that's your first interval over here, union 0 to 3, including both extremes. And that's pretty much it, what we have here, okay? Similarly here, what you are going to do first, you are going to factor, okay? So it's pretty cool to see that the factors over here, you have x squared minus 9x plus 20 divided by x squared minus 9 is greater or equal than 0. So when I factor the top, you know that that's going to be x minus 4 times x minus 5, okay? Okay, because we have this negative and this positive. And then at the denominator, you know that that one is the difference of squares. So you know that it's going to be x minus 3, x plus 3, okay? So you have that this is greater or equal than 0. So similarly, I'm going to put all the factors over here. So and you know that the numbers that I care in this situation are going to be 4, 5, 3, and -3. Okay, so I do my number line over here. Again, okay, so you have positive, then you have the -infinity over here. Okay, so the smallest number that we have is -3. Okay, so we have -3 over here. Then we have 3, 4, 5, and please note that it's not scaled because I need some space here to do all the work, right? So you have x minus 4, then you have x minus 5 over here, then you have x minus 3 and x plus 3. You can already do here your line if you want to, you know, compute the space there. Okay, so let's start. Okay, so you pick a number here, I don't know, -100. Okay, so you have that -100 minus 4, that's negative, this is negative as well, -100 minus this, that's negative as well, and this is going to be negative as well, okay? Then you plug the -3 here, which you know that it's going to be negative, okay? Then you have that here is going to be negative, over here the -3 is going to be negative, and here it's going to be 0, okay? After that, you know that a number between -3 and 3, that's going to be 0. If I plug 0 here, that's going to be negative. If I plug a 0 here, it's going to be -5, which is negative. 0 here is going to be -3, which is negative, and the 0 here is going to be positive, okay? So over here, I'm going to plug now the 3. 3 minus 4 is -1, which is negative. 3 minus 5 is going to be -2, which is negative. 3 minus 3, that's going to be 0. 3 plus 3, that's going to be positive. Then we plug a number in between 3 and 4. In this case, I would plug 3.5. Okay, if you put 3.5 here, that's going to be negative. 3.5 over here, that's going to be negative. 3.5 over here, that's going to be positive, and 3.5 here is going to be positive. Then I would put 4. 4 minus 4 is going to be 0. 4 minus 5, that's going to be negative. 4 minus 3, that's going to be positive. 4 plus 3, that's going to be positive. And then you need to plug a number in between 4 and 3. And not 4 and 3, 4 and 5. In this situation, I would plug 4.5. 4.5 minus 4, that's going to be positive. 4.5 minus 5, it's going to be negative. Then we have that 4.5 minus 3, that's going to be positive. 4.5 plus 3, that's going to be positive. Then we plug the 5 here. 5 minus 4, that's going to be 1, which is positive. 5 minus 5, that's going to be a 0. 5 minus 3, that's going to be positive. And 5 plus 3, that's going to be positive again. After that, last but not least, we're going to plug a number in between 5 and infinity. In this case, I would plug 6, okay? 6 minus 4, that's positive. Then you have that 6 minus 5, that's positive. then you have that this one is positive and positive. Okay, so that's what we have. Now what are you going to do with this? Well, you have that these two are at the top and these are at the bottom, so it's going to be negative times a negative, that's positive, divided by negative times a positive. So you have positive divided by positive, that is positive. Over here what we have is negative over negative, which is positive, divided by a 0. So this one is going to be undefined, okay, because the 0 is here. Okay, so you continue here, okay, in this interval. So you have negative times a negative, it's going to be positive. Okay, and then you have that negative times a positive is going to be negative. So positive and negative, that's going to be negative. Okay, after that, here you have that it's going to be negative times a negative, it's going to be positive, but it's going to be divided by a 0. So do I really care about the sign? Not really, that's going to be undefined. Okay, and over here you have that negative times a negative, it's going to be positive, divided by positive times a positive. You are dividing positive over positive, which you know that that's going to be positive. In this situation you have that it's going to be 0 divided by something, in this case positive, but that's a 0. Okay, over here you have that positive times a negative, that's negative divided by a positive, because positive and positive, so you have that that's a negative. Over here you have that it's going to be a 0 at the top and whatever at the bottom, because that's a 0. And then, well, as long as it's not a 0 here, right? Then you have that everything is positive, so obviously this is positive. Okay, so at this point you are like, what do I want? I even forgot what I want. I want this greater or equal than 0, so I want it positive. So where do you have it positive first? Positive, you have it here, here, and here. Okay, after that you are like, okay, I also want it equal to 0, so I want this guy and I want this guy as well. Okay, so what do you have here? Well, let's start with the one at the very left. You want negative infinity, then your answer, it would be from negative infinity to negative 3. Are you going to include the negative 3? Absolutely not. Okay, so you have union, and then what do you have? You continue here. What's that? That's my interval in between, so you start at 3 without including the 3 because it's undefined. Then you like the interval and you actually like the 4. Okay, so I'm including the 4. Here we don't want this interval in between 4 and 5 because that's negative, so we start at 5 including the 5. Okay, and then we go to infinity, and that's your answer. There you go. And that's your answer. So for this part, what you have is that you need to solve giving the exact answers in radians when x is between 0 and 2 pi, including the 0 but not the 2 pi. You cannot use a calculator over here. So a little bit of a refresher from Precalculus. Okay, what you have two options here. Either you use like the substitution. Okay, in this case I would do, if you want to use substitution, u cosine, let u be cosine of x. So here if you don't see it, okay, so you have 2u squared minus 9u minus 5 is equal to 0. After that you can see that you can factor the situation, and the factors are going to be 2u plus 1 times u minus 5, and that's equal to 0. Having that, technically in this situation your u is going to be equal to negative 1/2, and this u is going to be equal to 5. Then you go back to your u, which is cosine of x, having cosine of x equal to negative 1/2, and cosine of x being equal to 5. After that you can see that this one is one of the unit circle values. Okay, actually two of the unit circle values. Okay, so you can clearly see that from here you have that x is going to be equal to 2 pi over 3 and 4 pi over 3. Okay, after that you see that here this is not a real value, so these are going to be your solutions. Okay, so if you want to do the squigglies, you can do that. If you want to just leave it as this, that's correct as well. Okay, so those are your solutions. on this one, what you can see is like, well, this is a sine of x, so I can use the double angle formula here for the cosine of 2x. So I'm going to convert that cosine of 2x as 1 minus 2 sine square of x is equal to sine of x. This, how does this help me, you might ask? Well, I can see a quadratic term, a linear term, and a constant term. So I'm going to pass everything to the side that gives you the leading coefficient being positive, meaning I'm going to pass everything to the right side. So you have that 0 is going to be equal to 2 sine square of x plus sine of x minus 1. If you want to do the u substitution or the substitution again, you can do that. Letting sine of x being your u, you do see, if you are not seeing it, that 0 is going to be equal to 2u squared plus u minus 1, which you can easily factor out. If you don't need to do the substitution, don't do it. Okay, I'm just doing it in case that you're like, oh, how is she getting that? Okay, so you have u plus 1 times 2u minus 1 is equal to, well, I already have the equal to 0 on the other side, so there's no need on this side. Okay, so you have this. Okay, so obviously you have that your u is going to be -1, and the other u that I have, since I'm running out of space here, I'm just going to put the 1/2 there. Okay, so now that we have the u, you go back to your original, which was sine, so you have pretty much sine of x is equal to -1, and sine of x is equal to 1/2, and you need to solve each one. Okay, for this one, again, unit circle value, you do know that that one is going to be x is equal to 3 pi over 2. That's a really nice number. And then you know that sine of x equals 1/2, the sine being 1/2, you know that that's also part of your beautiful unit circle, and that's going to be pi over 6, 5 pi over 6. Therefore, your solutions are pretty much pi over 6, 5 pi over 6, 3 pi over 2. Those are your solutions. Okay, so let's go to another one that it's pretty similar, that it's this one. Okay, this one comes from algebra 2. Okay, actually you don't need the 3 decimal places because I don't even want the calculator, right? So if you don't remember this from algebra 2, remember that you're going to let your u be e to the power of x, having u squared, y squared, because you know the exponent properties over here work beautifully. So you have that this is u squared minus 3u minus 10 is equal to 0. So with this being said, what do you have? I can factor this equation pretty user-friendly. So you have u minus 5 times u plus 2 is equal to 0. And then you have that your u's are going to be equal to 5 and u -2. After that, you know that I need to go back to my original, that in this case is e. Okay, so in this situation, I have that e to the power of x is going to be equal to 5, which is very possible. Okay, and then you have that your other option is e to the power of x is equal to -2. After that, you remember, oh, I can convert this into logs. That's true. The only thing you need to be careful. This one works beautifully because I know that x is going to be equal to natural log of 5, and that's completely true because that's part of the domain, okay, of the logs. But what happens here? Can I put a -2 inside the log? Absolutely not. So this one doesn't give you any real solution. Therefore, what do you have? Your only solution is going to be natural log of 5, and actually I don't need the 3 decimal places because I have the exact value there. So for these last 2 examples, we're going to find the limit, obviously not using the calculator. So for the first one, we have that the limit of x that approaches to -4 of x cubed plus 64 divided by x squared minus 16. So the first thing that you might think of doing is, oh, I'm going to evaluate this equation and I'm going to evaluate it at -4. If you plug the -4 there, that's going to be -64 plus 64 and it's going to be 16 minus 16. So you have a 0 over 0, which is going to be a non-definition, which is a problem. Okay, so obviously that's not going to fly. When you do that, when you have that situation, what you're going to do is you're going to try to factor. In this situation, you can see that I can easily factor the numerator and the denominator. So using the sum of cubes here, you do know the formula of the sum of cubes is going to be x plus 4 times, and it's going to be x squared minus 4x plus 16. Okay, remember that this 4 comes because you know that 4 cubed is going to be 64, and that should give you a hint when you technically plug the -4 and it gives you the -64. Okay, so after that you're like, okay, can I then factor the denominator? And the answer is yes. It's the difference of squares, so you can see that it's x minus 4 times x plus 4. With this you can see that I can cancel that part. Okay, so rewrite your limit. So you have the limit when x approaches to -4, and you have that it's going to be x squared minus 4x plus 16. Okay, and that's going to be divided by x minus 4. So when we evaluate this expression with -4, what happens? Well, when we evaluate that expression using the -4, so you have that at least the denominator is -8. And what's going to be the numerator? The numerator is going to be 16 plus 16 plus 16. Score. That's 48. Okay, so you have 48 divided by -8, which this, you know that it's going to be equal to -6, and that's going to be your answer. Okay, so pretty user-friendly, honestly. Now, the next one that we have over here, what's the deal with this one? Well, you evaluate, you have the limit when x approaches to 0 of the square root of x plus 4. The -2 is outside the square root divided by x. Okay? So when I evaluate this situation, you know that this is going to be square root of 4, which is +2. 2 minus 2, that's 0. And then over here you have a 0. You have a 0 over 0 situation, which is again a non-definition, and it's a problem. And we're going to deal with this type of limits in the future, don't worry. But for now, what you need to do here is you need to fix the expression. Okay, the way that we're going to rewrite this expression is I need to technically rationalize. Okay, so if you remember how to rationalize, I need the square root of x plus 4. Okay, and that's going to be +2 over here divided by x plus 4 divided by +2. Okay, so I'm changing the sign of that one. Okay, so what you have here is what? Okay, so in this situation, what I have is going to be the limit, and please note that I changed that equal to a multiplication symbol. Okay, it's going to be the limit of x that approaches to 0, and then you're like, okay, then I need to distribute. Square root of x plus 4 times square root of x plus 4, that's going to be x plus 4. Then I know that since these two have a different sign, I mean, you can do the whole thing, right? They are going to cancel. Okay, so I'm going to do the whole thing. So this times this is going to be +2 square root of x plus 4. Okay, after that you have that -2 times the square root of x plus 4, that's going to be -2 square root of x plus 4. And last but not least, you have -2 times +2, excuse me, that's going to be -4. So you can see that these two, they cancel, right? Okay, so after that, okay, that you know that those two, they cancel, and in addition, you can see more things that they cancel. Beautiful. These two, they cancel. Wow. So I only have an x on the top. Okay, but before we deal with that, I'm going to put what I have here. What I recommend you to do here, do not distribute the denominator. Leave it like that, okay? So I'm going to leave it like that. X times x, square root of x plus 4 inside the square root plus 2, okay? So let me rewrite this so you can see everything. The limit that of x that approaches to 0, and then you have that x divided by x times x plus 4. And that one is not correct. Okay, x plus 4. Oh, let's do it +2. Okay, and then the parentheses here. Okay, and then you have that this is your line. Okay, so you can see that they cancel. Okay, so what are you going to do at this point? At this point, we have that it's the limit when x approaches to 0. Okay, and then what do you have here? You have 1 over the square root of x plus 4 plus 2. Okay, when I evaluate my my equation here using the 0, you have that it's going to be the square root of 4 plus 2. So here you have technically that it's going to be 1 divided by 2 plus 2, which you do know that it's going to be equal to 1 over 4, and that's it. Okay, that's your answer. Hopefully you find this video helpful. Bye.